Okay, so now I'm going to assume that you don't have a calculator, and I'm going to show you how to find how to calculate the critical T and the p-value using just pen and paper. This is going to be a bit tedious, so I'm going to jump a bit. I'm not going to show me actually filling it out for certain parts, but I think you'll get a pretty good idea. So first of all, we have the list of all the differences here. We have the formula for the critical T that we're going to be looking for here in a moment. Then we also have the list of things that we're going to need. So we're going to need the mean of the differences. We're going to need the standard deviation of the differences. We're going to need the sample size, and we're going to need the degrees of freedom. So the sample size is 10. The degrees of freedom is 9. All right, good. Halfway done, right? Now, what we have to do is calculate these two things. And again, we're doing it by hand. This problem didn't give us the mean or the standard deviation, so we have to actually list these out. So I'm going to go ahead and remember to find the mean, what you do is you add all of these values up and then divide by how many there are. So I'm going to add each of these up and then I'm going to divide by 10. This should be a negative 3, by the way. So I'm going to do that real quick. So yeah, when you added all of these values up, you got negative 28. So when you divide negative 28 by 10, you get negative 2.8. So the mean is going to be negative 2.8. Now what we have to do is the formula for standard deviation. Now this is a lot more tedious than the other one, because what we have to do is first find these. There's 10 of these, and it's each measurement minus the mean. So basically we're going to do 0 minus negative 2.8, negative 4 minus negative 2.8, and so on all the way down until we have all of them. Then we're going to square each of them, add them all together, and then divide by n, and then take the square root of that. So again, it's going to be a bit tedious. What I'm going to do is do it each step and pause along the way. So first, what I'm going to do is I'm going to take the mean and I'm going to find each of these differences minus the mean. There you go. This is the difference between each of these values and the mean. So I've taken each of these minus that value, and this is my list of numbers here. So then what I have to do, according to this formula, then I have to square that value. So I'm going to go through each of these and square that, and that's going to force all of them to be positive if they weren't already. All right, so here are all of these values. So these values squared. Be careful when you're doing it in the calculator. A lot of times, if you are not careful with how you square it, your calculator will give you a negative number. Just remember that any negative number squared is going to be a positive number, because any negative number or any number times itself will be a positive number. Anytime you multiply a negative number times itself, you're doing a negative times a negative, which will result in a positive. Just a quick reminder there. So now, according to this formula, I've subtracted each of these, I've squared it. Now I have to find the sum. So I have to add all of these together. So I'm going to do that real quick. All right, so there you go. I have this number represents all of these values added together. So now, according to the formula, I have to divide by n. So 57, this shouldn't be too hard. I can do this. Oh yeah, 57.6 divided by 10 will be 5.76. You don't really need a calculator for that. What you do need a calculator for is then you need to take the square root of that. So the square root of 5.76, I don't know, maybe you can do it in your head. I can't. Is going to be 2.4. So all of that for a standard deviation of 2.4. All of that work just for this. Amazing, right? All right, so then what we do is we plug it into our formula. This delta, this just represents whatever value we're testing it against. That's the mean we're saying it is in our null hypothesis. This is not just a triangle. This is supposed to be the Greek letter delta. And we're using delta because it's the differences and they both start with the letter D. It wasn't my idea. So anyway, we have a critical T with 9 degrees of freedom. The mean is going to be negative 2. Or sample mean is going to be negative 2.8, and we're going to minus 0, because the null hypothesis, remember, is that there's no difference. And then that's going to be over the sample's standard deviation, 2.4, divided by the square root of n, so divided by 10. So this top part's easy. This is just negative 2.8. And then the bottom part, well, first, what's the square root of 10? Turns out square root of 10 is 3.1622, blah, 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 blah. So we're going to do 2.4 divided by that number. And we get 0.7, I'm just going to round to 0.76. So our critical T is going to equal negative 2.8 divided by 0.76. Hopefully, oh yeah, there we go. We get negative 3.68. So not really too far off from what we did when we did using the calculator. I can almost guarantee that this is because of some rounding error. I cut off a lot here when I rounded. So it is what it is. But cool, there's our critical T. We know it's with 9 degrees of freedom, so we're going to go into our T table and find the row for 9 degrees of freedom. And we're going to go over to the right until we find negative 3.68, or 3.68 rather. It's going to be in between here somewhere. So in the one-tailed area, that's going to be somewhere between 0.005 and 0.001. So we'll go ahead and assume, well, we won't assume anything. We'll say the p-value is between 0.00, I don't know, you can't see that, 0.005 and 0.001. I got those signs backwards. Oops. That was dumb. There we go. Either way, the p-value is less than 0.05. Remember, our alpha that we said in the plan part was 0.05. So we can say that the p-value is less than alpha, which is what we're really interested in. So we would go and reject the null hypothesis.